When we were taking the classification of natural dyes, we had talked about various types of dyes according to their structural detail. We had named as indigoid dyes, anthraquinoid dyes, anthocyanin dyes, carotenoid dyes, and many such classifications we had dealt with. So far, when we have been doing the detailed study of these structurally important natural dyes, among them we have already discussed in great detail anthocyanin dyes or anthocyanin dyes with respect to rose, with respect to hibiscus. Then just this morning we took another detailed account of carotenoid dyes in terms of Delonix regia, and now we will take a look at a very important, very old, very ancient, yet very important dye from the anthraquinoid series, from the rubia or madder extract. Now, the structural detail, the chemical composition, the metal chelation and its dyeing effect, with the help of the innovative technology that we have developed using biomordants in this case, we have shown that rubia can be a very multifaceted dye. Also, because it is so largely used, or it has a big scope to be used in the industry. So, we tried to put up some innovative technological upgradation steps, so that this dye can be popularly used among the local people, and as well as not only for the domestic market, but also for the international market. For the simple reason that everybody likes to wear clothes which are dyed with natural dyes, and secondly, because this has that bright orangish brick red color, which is very appealing to one and all. So, that is the reason why we spent enormous amount of time trying to find out its large availability, and then its how traditionally it is being extracted and used for dyeing, and what are the steps that we can upgrade so that it can be industrially very useful. Rubia with biomordant was what we tried to explore in a big way. Rubia cordifolia or madder, or in Arunachal Pradesh it is commonly known as tamin, produces anthraquinone reddish orange dyes in the roots, stem and leaves, which have been used for dyeing. Now, one thing I wanted to make it clear right from the beginning, that we have been trying to popularize all those parts to be used which do not destroy the plant, and in case we use the roots of rubia, obviously the plant would be dead. So, we propagated the use of only the leaves and the stem, because the stem and the leaves have enough amount of dye, but the roots have the maximum amount. So, it does not matter, because we need not destroy the plant. Textiles since ancient times have been using this particular dye from madder or rubia. Commercial sonicated dyeing with rubia showed that pre-treatment with biomordant, that is urea acuminata DC var upricasta Karth from the Thiaceae family, also known as Nausanki by the Apatini tribe, Turku Nishi tribe, in 2% shows very good fastness properties for dyed cotton. So, here we were trying to concentrate on dyeing of cotton, because as I have told many times that cotton dyeing with natural dye is a big challenge, and we were trying to explore how to combat this challenge, and that is why we wanted to use this biomordant, and along with the cotton, how does the madder extract actually behave. Using dry powder of about 10% weight of the fabric is optimum. Use of biomordant replaces metal mordant, making natural dye completely eco-friendly. Now, time and again I am emphasizing on three main facts. One is, how do we bring about a technological upgradation in the process of extraction or dyeing? Second is, how can we replace the metal mordant, because that creates later on problems with the dye bath effluent treatment. And thirdly, how to enhance the light and wash fastness, which is the prerequisite for a dye to be accepted in the commercial market. So, this dye had no problems in its acceptance in the commercial market, because it is an ancient dye. But how can we bring about improvement through our technological advancement? And one such thing we did was to carry out the dyeing process in a sonicator. Now, sonicator ultrasound waves have a particular frequency of agitation in the dye bath, which is very good for dye uptake. So, this we had already established in the laboratory, and we were trying to explore with as many new dyes in order to establish its validity, because any process need not be valid for all the dyes. So, we wanted to show through our sonication dyeing method, which we introduced for the first time with natural dyes, that if sonicator bath is used for dyeing process, the dye uptake is definitely enhanced, and enhanced by several folds. It is not just that it is marginally enhanced by 1 or 2 percentage. It is substantially improved by 10 to 15 or sometimes even 20%. Now, in a commercial scale, this 20% extra dye uptake can definitely make a lot of difference on the hue color and also on the requirement for the disposal of the dye bath effluent. So, looking at the whole picture in a very holistic manner, one has to keep these points in mind, that dyeing with natural dye would require certain adjustments, and these adjustments should be beneficial in the long run, not only in terms of dye uptake, but also it should have good dye penetration, it should create good light and wash fastness, because that is the ultimate goal. So, we try to take the toughest material, that is cotton. We try to replace the metal mordant, which is the problem creating chemical in the whole process, by using biomaterial, and we called this as biomordant, and that biomordant was urea acuminata. Now, with this background we started exploring where all rubia is actually present, because you see we have to look for a plant material which should be abundantly available. So, the abundant source of rubia, a revived interest in the use of natural dyes in textile coloration has been growing, and there is a pressing need for the availability of natural dye yielding plants. This is a result of the stringent environmental standards imposed by many countries in a response to the toxic and allergic reactions associated with synthetic dyes. Arunachal Pradesh is recognized as one of the hotspots of the biodiversity, and the indigenous knowledge system particularly associated with extraction and processing of natural dyes from the plants, because it has very rich flora. So, the flora being so rich, it adds on to the possibility of finding many more dye yielding plant than what we have in the plains or at this altitude. So, altitude, latitude really makes a lot of difference, plus soil condition, climatic condition, everything adds on to different varieties of plants, and many dye yielding plants have been identified, and this identification was possible only because the local tribal people gave us this information that these are probable dye yielding plants. Also, although they did not know how to use it, and many a times their extraction procedure was much tedious, and as a result, because of the cumbersome process, they were not extracting the dye. Instead, they had now switched over to synthetic dye. But there were still pockets of tribes who were practicing natural dyeing. We met them, we took lot of traditional knowledge, information from them, and tried to document, because otherwise this information would be lost. And now is the time of the computer age where we have to document all traditional information so that it can be preserved for much later time. Traditionally, some of the dyes of this madder were being used by some tribes. From ancient times, some tribes of the state were engaged in natural dyeing. The different tribes, mainly the Monpas, Apatinis, Nieshis and Adis respectively of the West Kamang, Tawang, Lower Subhasiri and East and West Siang districts of Arunachal Pradesh, have been engaged in extraction, processing and preparation of dyes using bark, leaf, fruits and roots of the plant. So, since these were the few tribes which were at one point of time interested and were using natural dyes, we thought of contacting them because we could get the traditional knowledge from them. Our main focus, this work was designed with an aim to focus on the innovative methods of dye extraction, modern study and by means of application of modern technology to sharpen the skills of the tribal traditional dyers of the Arunachal Pradesh. Although a lot of work has been done on natural dyeing with Rubia, our approach is towards the development of eco-friendly natural dyeing using biomodern and ultrasound energy. So, what we tried to do, we did not invent a new dye, we did not discover a new dye, the dye was already there, but what we tried to do, because dyeing with Rubia extract or madder extract cotton was one of the biggest challenge that the textile industry would face, and we tried to ease out that process by bringing in the use of biomodern, taking care of the eco-friendliness of the process, so that less and less amount of effluent is generated and effluent which is non-hazardous, and most of the components should be biodegradable of that effluent. The second point was how to enhance the dye uptake, because the toughness of the cotton dyeing is because cotton is very reluctant to take up the dye. The dye penetration is very poor. So, is there any other method which can enhance this process? And yes, we have an answer. There is a process of ultrasound energy usage which can enhance the cotton, the toughest of the tough material, to have good dye penetration. Now, then the next step is to look for the characterization of the color component, because as I have been talking about, the dye compatibility, the dye structure compatibility with the fiber compatibility, unless until that is matched, the dye will not be taken up by the fiber. So, it goes hand in hand. Unless we have a good understanding of what is the structure of the dye that is in the madder extract, we will not be able to proceed. Rubia cordifolia mainly consists of alizarin as well as purpurine, pseudopurpurine, mangostin and rubiadine. Because anthraquinone dyes have poor affinity for cotton fibers, their fastness was often enhanced by moderns. Moderns, which are metal salts that form an insoluble complex with dye molecules, including potash alum sulphate, that is the common aluminum sulphate which is commonly called as alum, and with ferrous sulphate. The nature of modern dye complex is well documented in the literature, and it has been shown that this is how the dihydroxy compound of the anthraquinone moiety actually chelates with the aluminum. The trivalent aluminum then forms a bond, covalent bond with the dihydroxy, which are ortho to each other. So, this is a common structural detail of one of the alizarin. This is an alizarin molecule, and pseudo purpurine or purpurine are nothing but differently substituted groups that are present on the ABC ring, on the A and C ring rather. How does the chelation actually happen? The alizarin molecules are capable of forming 6-membered chelate rings with aluminum ions. Colored lakes formed by the metal ions and dye molecules resist extraction by water or organic solvent, which readily strips similarly structured acid dyes. The sheer size of the metal may or the complex may account for some of its insolubility. It is also likely that large complexes are physically trapped within the fiber. The ortho dihydroxy structure in the hydroxyl anthraquinone molecules could be greatly enhanced. It could be responsible for the chelation. A similar behavior is envisaged for biomoderns as well. So, just now I showed you that if alum is added to alizarin, how does the structure look like, and how does the chelation with the covalent bond forming between the aluminum and the oxygen of the hydroxy group present on the anthraquinone moiety can be envisaged. When we try to look at the details of analytical details of Urea acuminata plant, which is also one of the plants available in Arunachal Pradesh, and the tribal people told us that they always use this plant and co-extract it with madder, leaves, stem and roots. So, we did not know why they were using this particular plant, and in order to understand, and they said that the color definitely showed deepening and the fastness improved if they added this plant also at the time of extraction. Obviously, there has to be some kind of chemical which must be responsible for this dye enhancement. Only a small fraction of the plant species take up high level of aluminum in their above ground tissues. Generally, plants are classified as accumulators if they accumulate at least 1000 milligram per kilogram in their leaves. Our knowledge of aluminum accumulator is built mainly on the substantial contribution made by Chinnery starting some 50 years ago. The extract of Urea acuminata DC var apristacarth leaves is found to contain substantial amount of aluminum, and lo and behold, we found that it does contain aluminum, and that is what is playing a very vital role when the extraction process was carried out. Two possible ways of chelation is either the two hydroxy groups on the ortho position can chelate with aluminum, or the carbonyl and the hydroxy which are adjacent to each other can chelate. So, these are the two possible ways of chelation. So, in both the cases the aluminum still remains tridentate, but the oxygen when it becomes trivalent has a positive charge when the carbonyl is participating. Now, from the madder extract it was possible to identify, although the literature is already very full of the information that madder has these 6 compounds, that is we just named them, that alizarine, purpurine, pseudopurpurine, rubiadine and so on and so forth, and you will see that the basic skeletal structure remains the same. It has an anthraquinone structure, and apart from that it has oxochromes which could be different. It could be orthodihydroxy, it could be metadihydroxy, it could be metadihydroxy with a methyl group in between. It can have a carboxylic group in between, and it can have trihydroxy groups, or it can have trihydroxy with a carboxylic group. So, various types of structurally different compounds substituted or work the present in the madder extract. We try to analyze the aluminum content in urea acuminata. Atomic absorption spectroscopic analysis by this GBC Avanta model showed that the leaves showed 11.767 milligram per liter of aluminum content. The high aluminum content has been suggested to provide useful chelation to the anthraquinone moiety of the Rubia cordifolia at 2 different sites, one with the carbonyl and hydroxyl and the other with the dihydroxy moiety. So, we have shown both the structural details, how the chelation is possible at 2 sites and with 2 types of participation, one with carbonyl and hydroxy, between carbonyl and hydroxy, and the other one between 2 hydroxy. Once you understand the chemistry, it will be easy for you to understand why this urea was added at all. What was the role of urea? Because of the aluminum that is present, and that is enough amount of aluminum is present to do these 2 types of chelation. And because the madder consists of 6 different types of anthraquinoid dyes, it is not just one single alizarine compound, we have seen that. So, these 6 structures actually all are participating in the dyeing process, and that is why it is understandable to see that structure plays a very vital role in proper understanding of the chemistry of dyeing. Then we developed 2 different methods for dyeing, as what we have done mostly. We have used 2-step dyeing. In this, in the ratio of 2% biomordant, 2% with respect to the fabric weight was used as pre-treatment, and then the dyeing with Rubia cordifolia extract was carried out, which was about 10% weight of the fabric, and it was carried out for 3 hours at temperature between 30 to 40 degrees. The dyed fabric was rinsed thoroughly in tap water and allowed to dry in open air. Similarly, the process was repeated in sonicator, because every time we say that any method is better, we cannot just say it is better, but we have to make a comparison. The conventional method was compared with the sonicator method, both the 2-step method as well as the 1-step method. The ratios and all other parameters were kept at the same, except in the case of conventional method, it was heated to about 70 to 80 degrees for 3 hours, whereas in the case of sonicator, it was just sonicated at room temperature between 30 to 40 degrees, and it was not heated externally. 1-step dyeing process in the ratio of 10% Rubia extract and 2% biomordant was mixed thoroughly in one bath and the moist fabric was dipped for 3 hours at room temperature between 30 to 40 degrees. The dyed fabrics were rinsed thoroughly in tap and allowed to dry in open air. So, the process of the one step was that the mordant, that is the biomordant, was added to the dye bath. Simultaneous or metamordanting with biomordant was carried out. Effect of sonication. Now, as what I said, we tried to do both the process so that we can compare. In case of sonication, localized temperature raises and swelling effects due to ultrasound may also improve the diffusion of the dye extract. The stable cavitation bubbles oscillate, which is responsible for the enhanced molecular motion and stirring effect of the ultrasound. So, because of this particular agitation method, it is possible to do this in a much faster manner and in a more effective manner. In case of cotton dyeing, the effects produced due to stable cavitation may be realized at the interface of the cotton and dye solution. The dye uptake was studied during the course of dyeing process for a total dyeing time of 3 hours with and without ultrasound. So, that is what I meant, that conventional method and ultrasound method was done side by side, so as to come to a conclusion whether this method is better or not so good. About 58% exhaustion of the dye, that is rubia, can be achieved in 3 hours dyeing time using ultrasound, while compared to that only 40% in the absence of ultrasound in stationary condition for this dye, natural dye, was observed. So, there were very discrete and very different values. It is not just marginal enhancement. So, 58% vis-a-vis 40%, 18% enhancement is a big amount of dye uptake if one tries to look at the industrial process. Now, dye uptake due to mordant and biomordant also were compared, and it was seen that alum treated material, that means if a metal salt is used, then the enhancement as compared to the biomordant when it is used, you can see from the graph that the dye uptake in different medium, that is different mordant medium, one is alum added separately or biomordant treated fabric, shows this kind of dye uptake changes. The 1 stage and 2 stage dyeing of cotton fabric with and without biomordant by the natural dye Rubia cordifolia show that 2 stage process with biomordant showed very good results. The dye uptake in the case of 2 step dyeing is 9%, 23% and 11% for without mordant, biomordant and alum mordant respectively. So, you see that if no mordant was used, 9% dye uptake had taken place, but if biomordant was used, 23% of the dye uptake took place, and almost half of that or even less than half, 11% was taken up by the alum mordanted fabric. In the case of 1 step dyeing, the dye uptake is 38% and 47% for dye biomordant and dye alum simultaneous mordanting method. Now, there in the simultaneous mordanting method, we did not find the effectiveness of the biomordant Rubia cordifolia in better dye uptake may appear to be slightly less, but looking at the metal mordanting problems, however, the reduction in effluent pollution as well as improved fastness properties actually outweighs the benefit. So, the difference here is only 9%, but the enhancement, if you try to look at, so one has to weigh what is good and how can it be done. It is not always that you have to just look at one parameter. Of course, that one parameter, dye uptake, is the most important parameter, but effluent treatment, the cost of effluent treatment and all those, and the time consumption and the energy consumption, everything needs to be calculated when we are dealing with industrial processes. When we try to look at the fastness properties of the dyed fabric, we find that ultrasonic fabrics have superior fastness properties as compared to the conventional ones. And you will see that washing perspiration, rubbing, light fastness, everything, both the perspiration acidic and the perspiration basic, then rubbing dry, rubbing wet, light fastness, wash fastness, they are all lower in value when we look at the conventionally dyed swatches. But when we look at the ultrasonic dyed swatches, they are all one step above in the gradation scale. If these are in the 4 scale, they are in the 5 scale. So, one can understand that the fastness has also improved by the use of ultrasound. Actual aim of using any new technology should go in the betterment and in ways of either reducing the time, reducing the cost, or doing some kind of additional property which does not exist in the conventional processes. Then only it will be accepted by the industry, otherwise it has no meaning. It will just be an academic exercise and it will just remain in the laboratory and nobody will practice it. But in order to make it more popular, it has to have some added advantage. Another observation that we made was that it has a pH compatibility also. The pH of the Rubia cordifolia extract is about 5.7, whereas the pH of Urea acuminata extract was found to be 7.67. Now, thus it can be said that the two extracts are complementary to each other and that causes the better dye adherence. The suitability of specific biomordant, that is Urea acuminata or now Sankhi as what the tribal people call it, for this particular natural dye was evaluated on the basis of the traditional information collected. Now, we also try to look at whether it is making any pH change or whether it is really just adding as a source of aluminum. All those details we try to narrow down all the information, so that now every information about this new biomordant plant should be available to everybody. And that is why we try to do all this analytical methods to find out the amount of aluminum that is present in urea and the amount of the pH of each of these solutions and so on and so forth. Now, I would like to show you this graph particularly because if the dye concentration is represented by A, that is dye is the dye solution before dyeing, no fabric has been dipped. When alum mordanted fabric is dipped into this dye solution, it gives a graph of B, and when biomordanted treated fabric is dipped into the same dye bath of the same concentration, and that is how we were able to calculate the dye uptake with the help of UV visible spectrophotometer. So, it is not an arbitrary way of calculation, but whatever remains back in the dye bath is the dye solution after dyeing, and whatever has been the loss from the initial dye bath concentration to the present dye bath concentration has gone into the fabric. So, this difference actually gave us the percentage of dye uptake, and in the alum treated case it was 11.85%, whereas biomodern treated fabric showed 23.06% dye uptake. So, if we have to conclude, I would say that Rubia cordifolia, a very prominent anthraquinone dye, was found to have good agronomic potential as a dye crop in Arunachal Pradesh. Biomodern, that is Urea acuminata or Nausankhi, when used in conjunction with Rubia cordifolia, was found to enhance the dye ability due to the aluminum content present in its leaves. Enhancement of dye uptake was about 23.06% with biomodern and 11.85% with alum, and if no mordant was used, the dye uptake was about 9%. Use of biomodern not only enhances the fastness properties, but also gives good calorimetric data on dyeing. That is, the C-lab values, the LAB values, the K by S values were very good. Even the fastness properties in this case show very good results, and we have seen that ultrasound use has really brought the dye to a A grade dye category, even for cotton, where it was almost like C grade category because of the problems of the poor dye uptake and poor fastness properties and so on and so forth. The two-step biomodern dye developed for the ease of industrial application offers an eco-friendly process which should be popularized in an alternate method to the metal mordanted dye method. So, you see what we tried to do, we tried to summarize the whole process, or the dyeing process could be popularized in a different way by popularizing firstly the use of Urea acuminata in place of metal mordanting. Then in the process of dyeing we eliminated the conventional long method. On the contrary, we did the ultrasonic dyeing at room temperature, thereby saving the cost of energy and even time, and vis-a-vis we got benefits which were much important for a dyer because it showed very good dye uptake. As a result, the dye bath also had now lower concentrations of dye remaining for disposal. So, the whole process was developed with keeping in mind that how technology can be coupled with traditional information.